Now let's look at what are irrational numbers. Irrational numbers are the numbers that cannot be represented in the form of p upon q, where p is an integer, q is an integer, and q is not equal to 0. In other words, it cannot be represented as a rational number. If it can be represented, it is called a rational number. But if we cannot write that number in p upon q terms, where p and q are integers and q not 0, we say that number is an irrational. That is the opposite of a rational number. What does that mean? Let us take this example. Now, we have this square root of 25, and we know square root of 25 is 5. And 5 can be written as 5 upon 1, where 5 is an integer and 1 is a non-zero integer. So this is a rational number. In fact, all natural numbers are rational numbers. All integers are also rational numbers. Similarly, square root of 0.25 can be written as 0.5. So 0.5 can be written as 5 upon 10. Correct? 5 upon 10 is 0.5. And this can be further reduced to 1 upon 2. 5 ones are 5, 5 twos are 10. And this is an integer, 2 is an integer. So this is also a rational number. However, if you want to find the square root of 2, remember 2 is not a perfect square. So square root of 2 will not be a very simple looking answer. If you take the help of a calculator, square root of 2 would be approximately equal to 1.4141421373030488016887242009, and will go on and on and on and on and on. And at nowhere, no place, you will see that all these digits or the part of it is repeating endlessly. It never recurs. It does not recur. It does not repeat. It does not repeat its digits. But it never stops also. It does not stop. It is not terminating type also. It goes on and on and on. There are infinite number of digits. And the digits also do not repeat themselves. So this seems to be, means I cannot simply guess what will be the next digit and then what will be the next digit. It could be anything. Okay. We actually need to find the square roots to find all these digits. So such a number that never repeats itself, never recurs, and it never stops also, are called irrational numbers. Okay, means such numbers cannot be represented in the form of p upon q. It is not possible to write two integers, and if you divide those two integers, we'll get exactly this answer and all the other digits also that I didn't write over here. Similarly, square root of 3. Okay, taking the help of calculator, we'll find all such digits, and they do not repeat, and they also go on and on and on up till infinity. So square root of 3 is also an irrational number. What about square root of 4? Square root of 4 is simply 2, and all natural numbers are rational numbers. So square root of 4 is a rational number. Means square root of 4, which is 2, can be written as 2 upon 1, which is both are in fact integers. So square root of 2, square root of 3 are irrational. Even square root of 5 is irrational. Square root of 6 is irrational. Square root of 7 is irrational. Square root of 8 is irrational. But square root of 9 is a rational number. All these are irrational numbers. Because square root of 9 is 3, it's a rational number. Similarly, cube root of 1 is simply 1. So that's a rational number. But if you take the cube root of 2, it is 1.25992104 and all such digits. And there isn't any pattern in all these digits. There is no pattern. Okay. We cannot simply guess what are the next two digits. And they are not repeating, not recurring, and they do not even stop. They go on and on and on. There are infinite number of digits. So even the cube root of 2 is an irrational number. So to summarize this, irrational numbers are of non-terminating type, means they do not stop, they do not stop at one particular digit, and they are of non-recurring form also, means they do not repeat, or in simple words, there is no fixed pattern, or we cannot guess the pattern. Okay, so such numbers are said to be irrational numbers, and they cannot be written in the format of P upon Q, where both of them are integers. Now, in this video and in the previous video, we just saw that real numbers are made up of two categories, rational and irrational, or in other words, rational numbers and irrational numbers together make real numbers. Rational numbers could be represented in the form of P upon Q, where P and Q are integers and Q is not equal to 0. And if we see a decimal format, it could either be terminating, it means it stops somewhere, or if it does not stop, it will recur, it will repeat, it will have a particular pattern. But irrational numbers, they cannot be represented in the form of P upon Q, where P and Q are integers and Q is not equal to 0. And in decimal format, they are of non-terminating and non-recurring type, means they do not stop somewhere, they keep on going, and there is no fixed pattern, they do not repeat themselves. I hope now it's very clear what are real numbers and what are rational and irrational numbers. Thank you for watching.